Hello, welcome to the Simulocean Delft3D workflow tutorial. This video will explain how a new user can set up their project on the Simulocean portal, organize their input files, run their model, and finally visualize their results. To begin, a new user would need to create an account and sign into the Simulocean webpage. Once signed in, we're going to click on My Projects. You see that there's no existing projects, so we're going to click this button to create a new one, or up here, New Project. For this tutorial, we will call this Simulocean Tutorial. Okay, now when we click on our My Projects tab, we have a project that says Simulocean Tutorial under My User, under the group Simulocean. I'm not going to worry about domain right now. First, we want to look at model inputs. To get a better idea of what region we're going to be modeling, let's look at the overall grid. You can see the Gulf of Mexico down here, the Chandelier Islands, and then the Mississippi River coming out into the Birdfoot Delta. Our pressure sensors during Hurricane Isaac were deployed in the Breton Sound area just to the east of the Mississippi River. If you zoom in, this is our level 1 grid. We will call this our overall grid. And then down where we have the actual sensors and where we gathered bathymetry data, we refine the grid and we call this our level 2 grid, or our nested grid. And this has a fine enough resolution to allow us to resolve the shoreline. Now, to see which input files are needed in order to run a Delft3D model on Simulocean, we will start with our level 1 model. So these are our two folders that I'm going to use to upload to Simulocean. L1W is the overall model, and L2W is the nested model. For the overall model, we're going to start with our grid file, our enclosure file, and our depth file. Since this level 1 file is inside the Gulf of Mexico, a larger model needed to be run, and we will use that as a boundary condition. That can be found from our BCT file and our boundary file. Also, we have wind blowing over the surface during Hurricane Isaac, so we need to include the wind file for level 1 and for level 2. Then we also need to observe around the boundary for level 2. This file will be generated using the nesting1 command inside of Simulocean, but for now we need to give it a fake file as a placeholder. And then finally we need the master file that ties all those together. That's called an MDF file inside of Delft. So we bring that. Now we have everything we need for our level 1. Coming down here to level 2, we also need a depth, an enclosure, and a grid file. We need a boundary file. This is going to be the edge here. Notice though we only have a boundary file, not a BCT file. This will be generated using the nesting2 command inside of Simulocean. It saves us a lot of work. We don't have to do it ourselves. I'm observing at 2 points where we had pressure sensors located. So that's this L2W observation file. And then finally, the file that ties everything together, lets it know how long to run, what time steps. It's my MDF file. Now my L1W and L2W Simulocean inputs are ready to go. Going back to Simulocean, starting on the model input, it's inside of my project, Simulocean Tutorial. The model is Delft3D, and my description is my L1W overall model. They're going to call this model 9. It's a single domain, and since it's the overall model, it's not nested. Go ahead and save that. Coming back to my projects, now you can see my model 9. And if I hover over it, it gives me my description, L1W overall model. I'm going to also bring in my next model, same Simulocean tutorial, Delft3D. This is my L2W nested model. They're going to call this one model 10, single domain. However, this one is nested. This is a water level correction. We're not going to worry about it right now. The previous model was model 9. The nested run ID is L2W, and the prior run ID is L1W. Save this. Come back up to my projects. Now we can see inside of Simulocean tutorial, I have my two models. Model 9 is the overall, and model 10 is my nested. Now I need to add my input files to each of these models. Come up here to model, and I'm going to add some input data. So this is model 10, model 9 is my overall. I click on that and say add. And this is going to be from these are all of my input files. Upload them. Come back to my models. Now I can see that I have all my L1W input files. Do the same for my L2W. And now when I come to my projects, each of these models has input files. Going back to my projects, clicking on L2W. Now, my projects, I have my overall project, my models. Model 10 is referencing model 9. Now I'm going to start a job. My model input is model 10. This is my nested model, which is going to reference my model 9. I'm going to run this on Queen Bee, 4 CPUs, 2 hours. Give it a description, and I'm going to say submit now. Now this will give me the status of my job. Right now it's uploading the files. I can also view the status over here on simulation. It's already been accepted by Queen Bee and it is in the queuing process. Give it another minute. Then when I click on this job, it gives me all information, and this will give me the output from Queen Bee. This will automatically be updated every 5 minutes. So what I'm going to do is pause the video and then come back after 5 minutes and see what it's been doing. Okay, now that 5 minutes has passed, the last updated turns to 0. Our status is running. Now if I click on the job, I get the last 90 lines. You can see that our model has begun its computation. This is the level 1 grid. Apologize for this. This is the level 1 grid. Notice that we can't see everything, so sometimes we can download the output up to this point. And this is how it began. So Nest HD1 generated the boundary sections. And then Flow 2D 3D ran the initialization, and it's beginning the L1W computation. Once this is done, it will do the nesting 2 command, which will generate the input time series for the nested run, and then it'll run the nested run, and that's when we'll finally get our output. So from this page, we can monitor everything, and when this job is finished running, we will get an email, as well as this will say job finished and then data ready. That is the end of this video, and the next video will focus on what to do with the data once it's been completed. Thank you.